Drawn to scale shows two containers in the shape of inverted cones, and they are similar. So if they are similar, the ratio should work out. That's great, right? So given that the volume of the larger container is 65,000, show that the radius is approximately, well, we can do that. Okay, so we know that the volume, let me write it down, okay, is actually 1/3 pi, and the radius of the larger cone, I'm just going to call it r, right? Oops, let me write properly. Pi square h, okay, is equals to 65000. So 1/3 pi r squared, the height is 848, 65000. So that works out to be r squared is equals to we have 65000 over 16 pi. So r is equals to, well, we know it's going to be positive, so we can ignore it, the negative length, 0.960, which gives us 36.0 cm when rounded off to 3 simple figures, right? Part B, find the external curved surface area of the larger container using the radius 36.0. So the curved surface area is equals to pi multiplied by 36.0 multiplied by, well, making use of good old Pythagoras theorem, we have 48 squared plus 36 squared, and that works out to be 6790, rounded off to 3 significant figures. Got that? Okay. Moving on. Part C, the larger container is completely filled with water and is poured into 64 identical smaller containers. So means the ratio of the volume is 64:1, right? So find the vertical height of each of the small container. So what happens is volume of large, okay, to the volume of small is 64:1. Therefore, the height of large to the height of small is going to be the cube root, which gives us 4:1. And since the height of the large is 48, so the height of small cone is equals to 1/4 of 48, which gives us 12 centimeter, right? There we go.